Hello, children. So let's just try to solve this symmetry problems. So this question is actually known as, very popularly known as, resistor cube problem. So let's try to do this resistor cube problem. Each of the resistors are 3 ohm. So I've just written this 3 ohm separately. So all the resistors are 3 ohm. This is given to us. And of course, the diagram is given with battery and the direction of current flow. Everything is mentioned. We need to find the equivalent resistance here. And also we need to find the current in each branch. Okay. So now what we need to do is that we should start with any corner. Let's say we think about this corner. So you can see that the current is getting divided equally in the 3 branches, right? So I. That's why the total current, which is 3I here, it's getting divided equally I. Of course, this is taken as symmetry. So all that is given to us. This is the first thing. Now inside the cube, right, the current is traveling and there are different junctions. So mid edges carry 1/2, right? That is also mentioned in the diagram very, very clearly. Now the point is to identify the closed loops. So see, you can have the closed loop like this. Let's say current going from A to B. I'll just mark in red first. A to B, B to C, C to C dash. And then again coming back like this through this loop, right? So one more time. A to B, B to C, C to C dash. Similarly, you can think of any other branch. A to D, D to C, C to C dash, and then coming to the battery. A to A dash, B dash, C dash, and then. So you would have observed that all the paths are actually same, right? So like all are symmetrical. So we can just take any one. Okay, so that's why we are just considering one of the loops here. You can take any of the loops, but let's say any loop we can take, right? So I am just picking this one. A, B, C, A, B, C, C dash, and then coming back via this one. You can name it like C, C dash, E, A for your this one. You can name this, it's not, or you can just mention like A, B, C, C dash, A, this loop. So now, well, let's say we apply the Kirchhoff's law here. Okay. So let's take the same direction as the current is flowing. So if you go in this one, the first branch, what do you observe? The current is going this way. I am also going this way. So what will I observe? Minus IR. So this is, I'm applying KVL across this resistor. Then I come across this branch BC. So again, the current is in the same direction. I'm also going in the same direction. So this will become minus I/2R. Then the third one is again minus IR and then plus this E. So you want to take it as E or 10 directly, both works. Both the thing works. We can just directly put the voltage as well. So I can say minus 5IR/2 is equal to minus 10. Or I can say that 5/2 IR is equal to 10, which is also equal to this one, E. All right. This is the first thing. So now what is R? This R is 3 ohm. So if you substitute this R as 3 ohm, what will I get? 10 is equal to 5/2 into I into 3, or I will get 10 is equal to 15/2I This will give me I is equal to 10 into 2 by 15. So I get I as 4 by 3 amperes. Correct? So that means this current is 4 by 3, 4 by 3, and 4 by 3. The current in each outer edge is 4 by 3 now. And what is the inner edge's current is I by 2. So each, that's what they are saying, right? Or determine the equivalent resistance and the current across each cube. So each edge of the cube. So we can say that the outer edges is 4 by 3 amperes and the middle edges, or you can say inner edges, or you can name the edges, whatever, is 2 by 3 ampere. Now the total current supply by the battery is 3I, right? So that means the total current of the circuit is like total, I total is 3 into I, which is 3 into 4 by 3, which is 4 amperes, right? And then what will be the equivalent resistance of the entire circuit? V is equal to IR. So total, like whatever was the V by I. So that is equal to 10 by 4, which is equal to 2.5 ohms. So we can say that now the equivalent resistance is 5 by 2 or 2.5 ohms. And middle edges, inside edges, inner edges, I by 2 current, which is 2 by 3 amperes. And the outer edges, the current is 4 by 3 amperes. I believe now this is very, very clear. Thank you.